All right, so today we're going to talk about graphing and solving inequalities, or solving and graphing inequalities. And hopefully you'll remember from Algebra 1 that when you're graphing inequalities, if we have to graph x is greater than 4, all right, we just draw a number line. We put the number that we're graphing on it, and we put 0 on it. Now, when we're graphing everything that's greater than 4, we do an open circle on the 4, and we shade to the right. Or we shade everything greater than 4. If we're graphing x is greater than or equal to 4, we put 0 on the number line, we put the number that we're graphing on the number line, and then when we're greater than or equal to, we're including the 4. So when we're including the 4, we close circle on the 4, and we shade greater than or equal to 4. Or whatever the number is, right? It's not always going to be 4. If we're graphing less than, x is less than -2, put the number that you're graphing, the -2, and put 0 on the number line. And now, since we're only less than -2, we're back to the open circle, but we're shading to the left. And if we have x that's less than or equal to 1, we've got our number line, we put 0 on it, and the number we're graphing. Now, just like greater than or equal to is a closed circle, less than or equal to is also a closed circle, and we're shading everything to the left. Review, right? For the most part. All right, so when you're graphing your solutions today, that's what you're going to be doing. So, solving these inequalities. So let's solve and graph. Let's take a look at -3 times 2x minus 5 plus 1 greater than or equal to 4. All right, the first thing we want to do here is the distributive property on the left-hand side. So -3 times 2x is -6x, and -3 times -5 is +15, plus the 1 greater than or equal to 4. Next step would be to combine like terms. So our -6x plus 16 is greater than or equal to 4. Going to subtract 16 from each side. And negative 6x is greater than or equal to 4 minus 16, that's negative 12. All right, so we're going to finish this like we would if there was an equal sign here, but pay attention to this step. When you're going to multiply or divide both sides by a negative, we've got to divide by negative 6 here. When you multiply or divide both sides by a negative, you have to change the direction of the inequality. So these negative 6's cancel, our x falls down, our inequality changes directions. And negative 12 divided by negative 6 is positive 2. So that is our solution. X is less than or equal to 2. So if we graph it, we put our 0 on the number line, we put our 2 on the number line. We are less than or equal to, so we've got a closed circle. And we're shading to the left. Now, I'm going to cover this while we're here. Later on in your assignment today, you're going to be asked if the inequality is always, sometimes, or never true. Okay? Always, sometimes, or never true. In this case, when you get what I call a normal looking answer, x is less than or equal to 2, this inequality is sometimes true. Okay? It's true when the values of x are less than or equal than 2. Okay? I'm going to show you an example of always, and I'll show you an example of never as well. But in this case, this inequality is sometimes true. And the times that it is true is when your x is less than or equal to positive 2. Let's take a look at negative 2 times 3x plus 1. Greater than negative 6x plus 7. So if we do the distributive property on the left-hand side, negative 2 times 3x is negative 6x, and negative 2 times 1 is negative 2. We got a greater than negative 6x plus 7. So you need to notice this here. We got a negative 6x on both sides. So if we add 6x to each side, look what happens. We get negative 2 is greater than 7. Is negative 2 ever greater than 7? No, right? Negative 2 is never greater than 7. So there's no solution here. All right? This is never true. No solution. Let's take a look at 5 times 2x minus 3. Minus 7x less than or equal to 3x plus 8. So more distributive property. 5 times 2x is 10x. 5 times negative 3 is negative 15 minus the 7x less than or equal to 3x plus 8. Now on the left-hand side, we got to combine the x's. We've got a 10x minus 7x. And 10x minus 7x is 3x. The minus 15 comes down, and we're still less than or equal to 3x plus 8. Now, notice again, we've got a 3x on each side. So if we were to subtract 3x from each side, we get negative 15 is less than or equal to 8. Is negative 15 less than or equal to 8? It is, isn't it? Isn't negative 15 always less than or equal to 8? So this would be called always true. Your solutions are all real numbers. And that's similar to the infinite solutions that we dealt with last week. All right, so does everybody see the difference between always, sometimes, and never true? All right. If you had to graph all real numbers, you can just draw a number line, put the 0 on it. When you're graphing all real numbers, you include the 0, obviously. So we color it in. And now look which way our shading goes. It goes both directions to infinity. That's the graph of all real numbers. That's the graph of always true. The graph of never true, no solution. We do a number line, we put 0 on it, and then all it gets is an open circle. That's your symbol for no solution. We're not graphing anything. But on a quiz or on a test, they may ask you to determine if the inequality is always, sometimes, or never true, and choose the matching graph. So never true, here's its graph. Always true, here's its graph. And then the sometimes true is right here with its graph. All right, any questions? Your practice for today is going to be on page 38. (22), 23, and then 28 to 31. Now, I'm not giving you very many problems, so you should get them finished relatively quickly. Use that extra time to work in the ALEKS app. We're on a 4-day week. So there's only 4 days left in this week for you to learn your 10 topics. You've still got to learn 10 topics. We're going to do a study guide on Thursday, and we're going to take our quiz on Friday this week.